techniques. I know there are a lot of great options in this talk, so I asked you to be here. So my name is Shuya Mukai. I am a senior solutions architect at Epic Games Japan. So I usually support customers in non-game industry, but today I'm going to talk about Substrate for all industries. Especially for artists, no matter what industry you are in, I'm going to focus on helping artists learn how you can create material using Substrate. And Substrate comes from with some terms that might sound unfamiliar, like SSSMP or slab, and yes, you can a little tricky at first. So in this session, I'll definitely explain this term in a way that makes sense for artists. But just to be clear, this session isn't about breaking things down like a research paper. Instead, the goal is to help you actually make material with Substrate. So some of the logic might be simplified. So sound good? Okay, thank you so much. So here's what we are going to cover today. I'll give you a quick intro to Substrate first, and then I'll show you some of the new nodes and new inputs that weren't available in the legacy material system. And finally, I'll go over a few examples to show how you can build material with Substrate and how it works together with other existing features. And I have prepared a lot of screenshot of material node on this slide deck, and you can take a photo of that. And in addition, I'll share later the Unreal project file, which includes the example materials I will show you. So, what is Substrate? Substrate is a new way of authoring materials that gives you more control over the look and feel of your object across all platforms, like mobile, consoles, PC, liner content, virtual production, every platform that Unreal supports. The recently released 5.6, it's still in beta, so it's not quite ready for just yet, but we are targeting to be production ready and enabled by default in 5.7. So what are the new features of Substrate? One of the biggest points is that Substrate is based on principled BSDF. BSDF stands for bidirectional scattering distribution function. It's a way to simulate how light scatters, reflects, or gets absorbed on inside a material or matter. Okay? So within Unreal, what kind of features does Substrate usually actually have? One major feature is layering and mixing. Substrate lets you layer and blend material, and each layer estimates how light interacts, how it reflects, diffuse, and gets scattered and absorbed. Another big feature is the independent from shading model. Like in the legacy material system, you have to pick specific shading model based on the kind of material, like subsurface scattering, or clear coat skin, or stuff like that. With Substrate, that's no longer necessary. We don't need to choose a shading model. You can use multiple shading model at the same time. Like, for example, subsurface and clear coat together. So, Substrate has a lot of great features, but these two, layering, mixing, and shading model independence, are the biggest ones to keep in mind. Now, as many of you know, we can do things that seem layered in the legacy material system as well. We usually do that with something like blend material or lab node, right? So, but here's the thing, those methods don't actually account for how light is absorbed or transmitted to each layer. It's more like just blending colors without really simulating how light behaves in the material. With substrate, or more specifically with sub-BSDF, light interaction is handled much more accurately. I'll talk about it in detail a bit later. So each layer simulates things like diffusion, reflection, absorption, and even transmission. And what happens when you try to blend metals and non-metals in a legacy material system? Well, you get something like get an artifact like this, like a left hand. So this was the basic limitation of the old shading model. But with substrate, we remove the concept of metal and non-metal. So I think you'll be able to resolve this limitation. And all right, so that was a quick overview of substrate. Now, let's actually look at the new node and new input in grids. Once you enable substrate in your project setting, the result node or root node changes to something like this. In the older version, if you turn on the substrate, you could only use substrate material input. There was no legacy input support, right? So, but from 5.6, you can now use both legacy and substrate material input in the same project. However, even if you use legacy input, there are converted substrate behind the scenes. So it is possible to take over legacy material input, but we still recommend you enable substrate in a new or duplicated project. And if you connect the substrate BSDF node to front material input, it works as a root node for substrate, where you can convert it to right click. This BSDF node works a little similarly to the old result node or material attribute in the legacy material. They define how you can material looks and behaves. And one of the key BSDF nodes in substrate is the slab BSDF. You can use this to create pretty much any kind of materials matter. The basic idea is you plug in the things like color, roughness, normal into this node, and that defines your material. It's similar to the old result node. You might be wondering, okay, but why the slab BSDF? Well, slab is the composition of the interface in the medium. Some of you might get it right away, well, others might not, I think. Honestly, when I thought about it, I didn't really get it first time either. So I think it will make more sense once you see what input it takes and how it works. So for now, let's not go deep into that. We'll come back to this question towards the end. All right, now let's take a look at some of the new input in substrate. But since the inputs are well documented, I will just highlight the essential ones you need to know. So first of all, the diffuse albedo. This one basically works like a legacy-based color. It defines color of the material of the model. But please keep in mind that this is the diffuse color. So for metals, you usually set it black or 0. And in substrate, we no longer use metallic conspicuous. Instead, we now have F0 and F90. F0 controls how reflective the surface is when it's perpendicular to the camera. In other words, this is a specular color. So for non-metals, you usually use value between 0 and 0.08. For metals, you typically use a value close to 1. Of course, it depends on the look you're going for, but it means the color of metals is now controlled using F0. And about F90, this input controls the specular color when the surface normal is 90 degrees from the camera. So basically, it defines each specular color. In most cases, you we'll just leave this default value of 1. Like unless you're going for something a bit more unique or stylized or certain special materials. If you are used to the old workflow, this F0 and F90 might be a little bit confusing at first, but don't worry too much about it. You can still create material using familiar base color, metallic, and specular setup by using the metal elements to diffuse color F0 node. So if you have base color or metallic maps already, there's no need to remake them. You can just plug them in and keep working like before. There are also many other substrate helper nodes like metalness to F0 nodes to diffuse color F0. These nodes are designed to either help you recreate things you used to do with legacy materials, or to get some of the looks easily. And one very handy node in helper node is Substrate IOR F0. As we talked about earlier, F0 is physically based value, and you can actually calculate it from the IOR, index of reflection of a matter. Most matter have no IOR values, and they are easy to look at. Okay, so I'll show a bit more substrate helper nodes like this one later. So, all right, coming back to the input. Second roughness is useful surfaces that are lightly polished or mirrors that haven't gotten a bit worn out, like the one you see here. So this input can be a little confusing at first, but luckily there are legacy nodes for haziness to secondary roughness. With just a single input, haziness, you can create subtle sort of specular highlights that look a bit hazy or diffused. The next thing I'm going to share with you is glint. This creates the sparkling look you see in the things like snow or car paint. In the legacy system, you have to wake this effect using textures, which means you were limited by the texture resolution. But in Substrate, glint is built-in input. Interestingly, we set the roughness value to 1, we can get more glint. I'll show you 2 examples using glint later. And this is the last input that I would like to show you, SSSMFP. This one is actually one of the most interesting features in Substrate. Well, SSSMFP stands for Subsurface Scattering Mean-Free Path. Most of you probably familiar with subsurface scattering, but do you know what mean-free path is? So, MFP is physically measurable property of matter. This is the average of distance of a light of certain wavelength that travels before being absorbed into the matter and before it gets scattered. And this input lets you control how light is absorbed, scattered, or transmitted through a matter. If the light is mostly absorbed and scattered in the matter, you get a soft subsurface look. And if light travels farther, the material can even appear translucent look. For example, in this case of vector input, red and green travel about 0.2 centimeters, while blue travels about 0.9 centimeters before scattering. Does it make sense? I know, it's a bit of technical, but let's take a look at how this input is used in subsurface, translucency, and coating. If you want to use subsurface scattering, you can just input the color directly into the SSMFP slot. That's because subsurface is about how much light is being absorbed and scattered inside the material, right? So using color directly makes more sense in the SSMFP slot. So let's say you want to create something like red glass. What value should we put into SSS MFP? You might think, well, maybe I will just plug in the red color to SSS MFP. But that's not quite right, because MFP isn't about color, it's about distance. MFP represents how far light travels inside the object before scattering. And unlike subsurface scattering, some wavelengths in translucent material can actually pass through the object. So it's get a bit more complicated. Honestly, calculating the right value of MFP manually can be a pain. So that's where the subsurface transmittance to mean free path node comes in. It lets you work more intuitively. You just input color and thickness, and it converts them into MFP value automatically. And just like a legacy system, the transmittance color value is close to 1. That more transparent look. And if it's close to 0, sorry. If it's close to 0, it looks more opaque. And don't forget to set to correct blend mode and lighting mode when you make translucent material. And one thing to keep in mind when you're working with translucent material is that you will normally set the diffuse albedo to something close to black. For example, you set the diffuse albedo to black and then set transmittance color to almost red. What happens is all other wavelengths like green and blue get absorbed. Only red light gets scattered and transmitted to the model. That's what gives you the red translucent look. And let's talk about the coating. You can create clear coat effect using vertical layer node. Basically, this allows you to layer one slab on top of another, like a coating. The concept is similar to what we just saw the translucent materials. You can control the color of the coating using transmittance to mean pass node. You also have top thickness input, which controls thickness of the top layer. The vertical layer node actually runs several operator nodes. Operator nodes use to layer or mix different slabs. And these are the main ones you'll be working with the top 3 nodes. The select nodes was added in 5.6 and it works kind of like switch node. It lets you switch completely between 2 slabs. The add node, on the other hand, literally adds one slab to another. But for your information, adds breaks energy conservation, so it's not physically accurate. The substrate horizontal blend is used to blend 2 slabs horizontally. The mix input controls how much of each one you see. If it's set to 0, you only see the background slab. If it's set to 1, you will see the foreground slab instead. It works similarly to lab node, but it's for full slab. So not just on values. This is really useful things like dot mask, paint chipping, or any material breakup where 2 surfaces need to be mixed together. The coverage weight node is typically used together with vertical layer node. It's great for situations where you want to mask out part of the coating. When the weight value is set to 0, the top slab, which is the coating, is completely hidden. When it's set to 1, the top slab is fully visible, just like a normal vertical layer. So it gives you pixel level control over where the coating shows up. Now let's take a look at the difference between just using vertical layer and using vertical layer with coverage weight. On the left, we have basic material using standard vertical layer. The top slab pre-coats the bottom. In the middle, we are using checker texture to vary the top thickness input. Some areas set to 1, others to 0. But as you can see, even where the thickness is 0, there's still a visible clear coating. And on the right, we are using the same chicken texture, but this time we are plugging to the weight input of the coverage weight node. And now you can see area where the weight is 0, there's no coating at all, right? So that shows the difference between varying thickness and varying coverage. And what's the difference between vertical layer plus coverage weight and horizontal blend? When you're blending opaque slab, you will often get a very similar visual result with either method. But the key difference is the horizontal blend isn't layering, it's just mixing. That means the foreground and background foreground and background slab are blended. You don't see through the foreground to the background. So if you're trying to place a translucent material on top of an opaque one, horizontal blend won't be the right choice. So we are going through the most of the important input and nodes for building a material with substrate slab PSDF. So let's go back to the question we asked at the beginning, what is a slab blend? Slab is a composition of an interface and a medium. The interface is where light interacts with the surface of the material. It defines how light reflects or reacts on the surface. And it's mostly defined by things like roughness, normal, diffuse albedo, F0, and F90. The medium is volume underneath the surface, where light is scattered, transmitted, or absorbed inside the matter. This is the most defined by SSSMFE, and so some extent diffuse albedo. In other words, substrate slab BSDF is designed to simulate them based on the real-world physical principles. Of course, there's exceptions, but in many cases, you can replicate the look of real-world matter using this slab BSDF. Well, with that said, I know some of them might still feel a little hard to grasp, right? So let's get deep into some real material example using substrate. I put together 5 different materials, and I also include some of the newer features from UE5. The first example is accumulation of snow. I'll show you how to create some material using nanite displacement. In this scene shown here, snow is layered on top of the various megascale assets. I'm not replacing the base material. I've just added a snow effect on the top of the existing megascale default materials. So here, for the material graph, the part highlighted in the red is the material which comes from the default megascale asset. So we won't be covering that section today, but because there are some other important points that I'd like to share with you today. Let's start by looking at how the snow part of the material is set up. This section here is the snow slab. For the textures, I'm using snow maps from Megascans, so you can get realistic detail right out of the box. One key part of the setup is glint. It adds variation to highlights and creates the subtle sparkly effect you see when snow catches the light. It's a bit hard to see in the screenshot, but it's like here. I also recommend set the SSSMFP to light bluish value here. It gives the snow softer and a more natural look. And this part handles snow mass. Basically, it lets us control where snow accumulates of the object. Nothing too new here, but I'm using pixel normal nodes to isolate the top-facing part of the mesh and use that as a mask. The snowman parameter controls how much snow builds out. It will be connected to the displacement, and it affects the height of the snow of the surface. Just to let you know, the nanite displacement was introduced in 5.4. As many of you know, displacement as actual surface detail based on grayscale height map or grayscale displacement map. The challenge with displacement is that it requires very high mesh density, which makes it impractical for real-time rendering in the past. But thanks to Nanite, we can now tessellate mesh in real time, and Nanite displacement also works on the landscape. Here's a setup that adds snow to the original material. I'm using horizontal blend to mix the snow slab with the original material of the object. The mix value is driven by snow mass we created earlier. By multiplying the mass with the snow displacement texture and feeding the result into the displacement input, we are able to control both the overall snow shape and the fine surface detail. And carpet is a perfect real-world example for showing what you can do with substrate. That's because carpet is naturally a multi-layered material, which shows how substrate handles layering. Carpet is also a good example of glint. When you want to simulate metallic plates, like you see here on the food, you see like a shiny part. So getting a bit more technical, carpet is actually made up of multi-layered, like this graph. You can see that at the top, you have the clear coat, and followed by the base coat, which defines the main color. And underneath that main coat is the primer layer, often with metallic plates on the primer. Of course, that exists structure varies by manufacturer and model. It will depend on maker, it will depend on model, but this is a common overall setup for any carpeting system. With Substrate, we can recreate this multi-layer structure directly in the material, and each layer can be physically defined and rendered. This is the bottom layer of the slab. It's just a primer layer plus glint. It's a fairly simple setup, right? So just a metallic surface combined with glint to simulate the sparkle effect for metallic plates. For the glint mapping, I'm using a three-planar projection. Like here, it works cleanly even on the CAD model that may not have UVs. The MFT three-planar UV function here comes from the automotive materials tag. It's available in the part. And by the way, just to let you know, we are also planning to release substrate version of the automotive materials tag. I'm sure it's going to be useful across a wide range of industries. This is the middle layer, the base layer. This one also pretty simple setup. We are using transmittance to add a blue coating over the primer layer underneath. That's what gives the material its richer color and which allowing us to see the metallic plate from the primer to the blue coating. And finally, we have the clear coat layer on top. In the legacy material system, you could only add a single clear coat on top of your base layer. But with Substrate, you can build a two-layer structure, and not just that, but you can also control the thickness of each individual layer. This gives you much more flexibility and realism, allowing for richer, more bearable, barely carpet material than ever before. This is great news for people who will be working with carpet. Substrate also make it easy to create a material like this image. We can see the color shift based on the view angle, like a camera paint. Substrate includes a feature called specular profile, which lets you control specular color based on the angle. You can assign the specular profile asset each individual slab. Inside that asset, you define the specular color using either color round or 2D texture. We have two large format options as sampling methods, view or light and hand angle. In the view or light view or light not format, we have two controls, view color and light color. View color defined on the camera angle at its left side. So, and if the value, the view color of 0 represents the color singling gradient angle. And if the value is 1, it defines the color when the surface is viewing right in front. On the other hand, light color works based on the light angle. A value of 0 means the light is hitting a shallow angle. And value of 1 means the light is coming straight onto the surface. Together, these features gives you very fine control over how the specular behaves. And here's a node setup and route for the Cameron paint example I showed you earlier. The only change here was made in the base coat slab in carpet material. Everything else, like a clear coat, remains the same. So, is it okay? Can I move on? Yeah. So, I'm going to show you our next example with paddle. For this material, I'm using mesh texture painting to let artists paint paddle wherever they want. Artists can directly paint on the mesh surface. And you can also create oil-covered paddle like this easily. Let's take a look at how it's actually set up. Here's a full material graph of paddle, and this part focuses on the asphalt pitch slab. I'm using Megascan textures here as well, and this part, there's nothing special going on. This is a slab for the water layer in the paddle material. I'm using transmittance to mean free path to control the transparency and the color of the water. I've also added just a little bit of normal detail to slightly dissolve the reflection. This small tweak really helped make the paddle more natural and realistic. And for the oil effect, I'm using the Substrate thin film node. With the thin film node, you can easily create iridescent material like soft bubbles, or slickers, and more. This effect comes from how light interacts with very thin layers of material, just a few micron thickness. It's causing color shifts and distinct grain pattern like here. That's why the thickness input is important. In most cases, we use grayscale texture and adjust its range using a lab node to control thickness variation. This thin film is connected to the F0 and F90 input of the water slab. In my setup, I added a switch node to toggle the oil effect on or off easily. That way, I can use same material for both normal paddles and oily paddles. I'm using vertical layer node to stack the water slab on the top of the asphalt slab. If we use only vertical layer, the entire surface would be covered. So we are using coverage weight as well to control where the water actually appears. For the weight input, I use mesh texture color paint, which let me manually paint paddles wherever I want it on the mesh. In terms of mesh paint, with existing nanite meshes, we can store or paint per instance vertex colors directly in the level, right? That's where the mesh texture color paint feature from 5.5 comes in. It allows each nanite mesh instance to have and use its own paintable texture, which can then be used directly in the material. This one is very easy to use. If your material in your material, use the mesh paint texture object node to access a texture associated with each instance. The mesh paint texture replace node lets you define the format using default value when no texture is present, and then you switch to painted texture if there is one. Once that's set up, you can go into the level and start painting directly on each static mesh instance using the mesh paint mode. Okay, instead of using the painted mask by the mesh painted on its own, I multiplied it with the asphalt height mask, and then I use the result to plug into the top thickness input of the puddle layer. This allows the puddle to show the natural bands and dips on the asphalt. In the shallow areas, the higher part of asphalt texture remains visible, making puddle looks more realistic. So, in our next example, we have a river material. What's interesting here is everything, the riverbed, the water, and the floating leaves, is created using just one single material. Here you can see the full material graph for the river setup. To give the riverbed rocks more three-dimensional look, I'm using parallax fusion material. While displacement could also use it requires combining all three layers displacement values, which can make things pretty complex. So in case like this, parallax occlusion mapping will be much more practical and simple solution. This is a slab used for the riverbed. While parallax occlusion mapping isn't a blind technique, but it's still very useful. With just a node setup and the height map, you can easily add surface detail. Thankfully, many megascan surface assets already include the height map. Normally, parallax goes through into UV input of texture sample, right? But here we are adding a small amount of water normal to the result of parallax. That gives us a nice underwater distortion effect, kind of like refraction, but way cheaper. This is a slab of the river water, just like the previous example. I'm using SSS MFP to control the color and the transparency of the water. But in this case, the water layer is much thicker than, for example, the puddle or glass, right? So therefore, instead of using transmittance node, I input value directly to SSS MFP. In this case, it's just easier to control the way. I'm also using the substrate IOR to F0 node here. So it's faster way to get the F0 value from the mother IOR. For the fallen leaves, I'm simply using an atlas texture. There's nothing special. In this slide, we can see how the three slabs are layered and blended. The water slab is layered on the top of the riverbed rocks using a vertical layer node. By plugging the log height map into the top thickness input, we can control the received depth of the water. This thickness value aren't physically accurate, but they are tuned to get the best visual result. In this example, there are only one layer of leaves, but to make it more realistic, you could easily keep another layer of leaves between the logs and the water as well. Finally, let's take a look at this checked glass example. Real glass has thickness, right? So when it lays, we typically get the depth and structure in the glass. With substrate, you can achieve a convincing layer cracked glass effect easily, while capturing a sense of the physical depth. This material is using 3 slabs. As shown in this diagram, we can see that the cracked slab is sandwiches between 2 layers of glasses. This layering helps simulate the depth and thickness of real glass when it shatters. But the problem is it has a higher performance cost. So using this setup really depends on your target platform and performance budget. We can see the glass slab here fairly simple. It's a slightly thick glass with subtle color. By the way, diffraction can be very expensive, so it's not something you will want to use in every case. With that said, enabling diffraction just affects how roughness behaves. and it can help achieve more realistic results when needed. That's especially true for things like dirt or prosthetic glass. The crack is built as a simple translucent slab using transmittance to meaningfully path. But we use product occlusion mapping again with a normal map and a grayscale mask texture to get the depth of the crack. You can clearly see the difference with and without parallax occlusion mapping in the image below. The result with POM has a much more realistic 3D
Itu masking doang pakai alpha texture.
This
Tadi
dust
kakaknya,
here is
gue kira itu
also quite
prosedural.
simple. It just uses a grayscale dot mask texture
Jadi aku
to
gampang
introduce variation
kalau
in the
misalkan mau gampang
roughness.
tinggal di overlay juga bisa.
Here, we are layering the crack slab on top of the glass slab using vertical layer node.
Realistiknya sih.
The crack slab itself is a simple translucent layer, but by plugging the parallax-driven texture into the coverage weight input, we can get the appearance of depth on dimensional in the cracks. On top of that, we add another layer of glass and then apply that layer with it. In this case, the dot can be blended using either a horizontal blend or another vertical layer. Both methods will give you fairly simple, similar visual result. But horizontal blend is a little more performance friendly. When building this material, a warning like this may appear. It's here, substrate material was out of budget and has been simplified warning. Well, let me talk about why this warning appears. Substrate has a byte budget per pixel, and as you add more slab or operators such as vertical layer and horizontal blend, that cost will naturally go up. If the material exceeds the fixed budget, Substrate will automatically simplify the material blended using a feature called parameter blending. This keeps the material within budget and features that the project performance is maintained. And each additional slab roughly double the cost of the lighting evaluation. However, if you enable use parameter blending on a horizontal blend or vertical layer, Substrate can merge two slabs and evaluate them as a single unit, which rarely reduces the cost. Once you enable it on the node, it applies to all slabs below. In our example, with all slabs, the cost is 104 bytes. And when we enable parameter blending on the bottom horizontal blend, like here, the cost drops to 85 with no noticeable visible change, like here. But when we enable parameter blending on the topmost vertical layer, like here, the image all four slabs into one. This procedure brings cost down to 24 bytes, but without more visual change. So Substrate will do this automatically when the material exceeds the per pixel byte project. It will depend on how much simplification are you willing to accept, and where does the performance matter the most. We can also change the substrate budget using a console variable. The variable is output substrate price per pixel. I recommend adjusting it depending on your target hardware or performance goals. There are also other performance considerations such as topology and closure count, both of which can impact rendering costs. I'm sorry, we don't have a lot of time to go into all the details today, but if you'd like to learn more about them, I highly recommend checking out this section from Figure 2023. It's a great deep dive into Substrate, presented by amazing engineers in admin. I personally found it really informative. And you can download the project file with all 5 material examples from this session. Please note that Megascan's assets are not included due to the license instruction. Sorry. But I've added links to all the Megascans or part assets I use. And you can download them and recreate the same way. I hope this material gives you some inspiration and help you start creating your own material with Substrate. Well, I'd like to conclude here. Thank you so much for your time and attention. So we have meetings. Do you have any questions? Yes. Maybe. Staff brings mics.
Now we are waiting to get back to the studio and change to substrates, but our materials are using for effects, room, skin, everything are using complex material. So everything is going to be converted natively to use substrate features, right? The way they calculated those subsurface and all those fancy stuff. Or you have any suggestions after we get back and hit the convert right in the project?
So you mean how much the cost to convert it from the original legacy material to substrate?
Yeah, we need some suggestions after we get back and hit the convert to substrate or enable the substrates. Any suggestions, something along the way, or any procedure to do it?
Yeah, basically, if you enable the substrate setting, we can automatically convert it to substrate. But some of them are like, substrate has a lot of layering features, right? But we can convert it to using a layering. So you have to remake like a layering. But like a skin or like a, you said skin, right? So I would think like a skin material, I would think you don't need much more time to remake the material. Maybe almost automatically convert it. Does it make sense?
Some of the things are going to break, but still a lot of things are going to
Yeah, it depends on the I'm sorry. So yeah, most of the material we can convert to automatically.
Thank you very much.
Thank you much.
Thank you for the call. You mentioned earlier that it will be enabled by default on 5.7, and there is an option to use legacy material on projects with Substrate enabled, and it could just run with the conversion layer automatically. Can we expect it to? How easy would it be to redo an old project in 5.7 or 5.6 is Substrate enabled? Should we expect an easy one, or like all classes of materials, not talking about skin, but like building glasses, asphalt, stuff like that, like rough material? Would that be an easy transition, or should we work into it? Like, what can we expect?
So, I'm sorry, could you say that again?
Sorry, I'll try to repeat the question. So, you mentioned it would be enabled by default soon.
5.7.
On 5.7.
Yes.
When that happens, there will be an option to use legacy materials, because previously, once we enable Substrate, we can't use legacy materials.
Oh, okay.
So if we don't convert some of the materials into Substrate, there will be a conversion layer you mentioned earlier. Would that be a foolproof conversion method, or do we still have to put work into it? But like other than skin, because skin is already asked.
Yeah, in 5.7, if just a target to the project ready, and we also we still have the check like a setting checking box, so you can disable the substrate as well, and it's it depends on it's up to you. So you don't have to use substrate, and you don't necessarily to use substrate. So it depends on you, our choice and the project. So if you use that 1.7, you continue to use legacy memory system.
I think the question was more like, if, say I want to enable substrate, but I don't want to bring all my old legacy material into substrate, would the conversion layer be good enough for me to not have to meddle with anything?
Yeah.
Oh,
So, yeah, it's time up. So, all right. Thank you so much again, and enjoy the rest of our FS.